Hello Year 12 students, this is Mr. O, and I'm going to be doing another question, question 6, specifically on axial or angled loads. I'll be doing this question right here. So let me jump straight into it. So what I have is, I have two supports. Number one, I want to redraw this. I have two supports. I have a fixed and pin support, and I have a roller support. You can see by the little rollers underneath. There's my beam. I'm not going to be overly complicated, and I'm going to draw a force number one, 500 newtons. Somewhere around here there is another force, which is 30 degrees from the parallel, or from the from the horizontal, and it is 200 newtons. And then I have one over here, which is a higher angle, 60 degrees from the horizontal at 500 newtons. This is a roller support, so it should be supporting via only one vertical load. It's my RR, my reaction at my right. I've been asked to calculate the reactions of the supports. This is going to be vertical only, so I'm going to just call it force right vertical. This is a fixed support, so it is going to have a vertical and a horizontal. It is my R left, and I'm going to call it force left vertical, force left horizontal. I've made it go up positive because I assume it's a positive, and I'm going to make it go right because I assume it's positive as well. I've done the same with that. Distances, just so that I make sure I do not make any errors in my calculations. 2 meters from the end. Let's have a look at just quickly, let's have a look at the units. Newtons, newtons, newtons. Okay, good. Meters, 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 meters. So they're all meters in distance, and they're all newtons in force. 2 meters to there, 3 meters between those two, 4 meters between those two, and 2 meters between those two. So I've got a good idea. So what's the length of the beam? It is going to be 2 plus 3 is 5, 4 plus 2 is 6, is going to be 11 meters long. I also have a normal perpendicular load, and I have an angled load, and I have another angled load. So I have to resolve both of those to what do you call it, to their vertical and their corresponding vertical and horizontal forces. Quickly do my assumptions. I've not been told it is out of equilibrium. So if it is in equilibrium, sum of all my moments equals 0. A moment is force times distance. To calculate a moment at a particular point, it's going to be the force times the sum of the force times the distance of all the forces, whether they're clockwise or not clockwise, or counterclockwise. Clockwise is going to be positive. Counterclockwise or anti-clockwise is going to be negative. The same when it comes to the sum of all the forces horizontal and the sum of all the forces vertical. And I can work it out specifically, like all my forces pushing upwards will be positive, all those vertical forces pushing downwards will be negative, and the same horizontally. All my forces pushing to the left will be negative, all my forces pushing to the right will be positive. That's because the sum of all my forces, vertical or horizontal, will equal 0. All these forces will cancel each other out, and all these forces will cancel each other out, and all the moments turning in the different directions will cancel each other out. They should be equal to 0. So let me have a look at, I'm just going to call it 1A, which is I'm going to resolve the forces, the vertical and the horizontal forces of that, and I'm going to resolve the vertical and horizontal forces of that. So first one, it is 30 degrees. I pretty much drawn it like 45, which is not good. But if it's 30 degrees, it is going to be, the forces vertical are going to be less than the forces horizontal. Let me just do that a little bit more accurately. There's 30 degrees. You can see that visually. Straight away, my hypotenuse is 200. And I'm going to try and work out my adjacent, which is sine of that angle. So FV equals, write this down every time you do this, just so that you remember, hyp sine 30, which equals 200 times sine 30. After a while, you'll be able to do these in your head. You'll know them so well. 100 newtons down. Force horizontal is going to be half cos 30, which equals, and as I said, it's going to be bigger, 200 cos 30, 200 cos 30, 173. That makes sense. 0.2 newtons, and if I look at the way it's drawn, it's pushing that angle will be down and to the left. Force horizontal. So that's for my first one there. My second one, it is 60 degrees. 500 newtons. Because of 60, straight away you can see that my force vertical is going to be greater than my force horizontal. And that again is going to be force vertical is hyp sine whatever that is, 500 sine 60 equals 433 newtons. Everything's in newtons. Force horizontal is hypotenuse cos theta. 500 cos 60 is 250. There we go. Makes sense. 200 is smaller than 430. So I know now what the normal 90-degree force and horizontal, the vertical force and the horizontal force for each of those. And my next step is to then solve for one of these. I could take a moment around that one and just calculate it as normal, but I'll just start on the left-hand side because it's kind of what we do all the time and it's simpler. In your exams, you might get these two swapped around. It doesn't matter. You just continue to do your moment calculations, working out as if this point is a seesaw and whichever way that force is going to drive it, clockwise or anti-clockwise. So straight away, we say, take moments about the reaction on the left to solve for the unknown, because it kind of is removed from the equation when you do that. So you really only going to have one unknown. That's why we do it like that. To solve for RR, which really is going to be a single vertical force, which is R right vertical. I'm going to quickly do that there, where I say sum of my moments equals 0. My moment calculations will be the sum of all the force times the distances from that moment point. And that's really it. So I'm going to go there. 0 equals positive all my moments, force times distance in the clockwise motion, less the forces, the moments in the counterclockwise moments, primarily because I've already assumed it up there. On my clockwise or positive, or my anti-clockwise or negative. As I said, I've solved it in a number of videos beforehand where you can choose that. You can do it the other way around. In the end, as long as you stay consistent, you'll still get the same and correct answer. Let us solve this. Now, I have a look at this point and see which force is going to cause my beam to have a moment in the a turning effect moment at that point to be clockwise. So I'll do that. It's going to be quite a large calculation, so I'm going to make it really nice and neat. That's going to be force times distance, 500 times 2 meters. Everything is in newtons, so it's 500 times 2. Plus, my next one is going to be this force here. But its perpendicular force causing this beam to pivot clockwise is 100 newtons. That's its vertical force down. It is 100 newtons, but how far away is it? It's not 2 meters, it's 2 plus 3, it's 5 meters. There's your lever effect working. And I've got another one over this side, and my vertical force is 433. Times how far? 2 plus 3 plus 4. So 4 plus 3 is 7, 8, 9 meters away. I have no other forces that are causing this beam to pivot this way. I don't have a overhanging beam which comes out to this side and is pushing up that way, so it really just stops there. I then now look at what other forces are pushing upwards to cause this, obviously ignoring that left-hand side. I've really just got that, and it is 11 meters away. So it is negative 11 force right vertical. Let me calculate this. What I could do is do it all in one in the calculator, and I hope you can see the calculator from there. So it's open brackets. I'll do 2. 500 times 2. 5 times 2 is my distance. It's pushing downwards. Close brackets. Plus 500 times 5. Just double checking. Plus 433 times 9. Yes, that's it. And that should give us all of that added together. That's my Newton meters, that's my turning moment, because technically it's force times distance, newtons times meters, so that's so many Newton meters, minus 11 FRV. Take this to the other side, it becomes positive 11 FRV equals 5397 divided by 11. .63 newtons. It is positive, you know it's driving upwards. Because it's positive, it is upwards. Always put the arrow up just to make sure, because you don't know what your teacher's marking schema or allocation, where they allocated marks. Sometimes they would like to make sure that you know from an understanding perspective whether it is up or whether it is down. Okay. Well, we've solved the reaction for that side already. We've got an idea of what these all are. We've resolved them to their vertical and horizontal forces. Now we're going to do force horizontal. And so force horizontal, realizing the forces to the left, the sum of the forces to the left should equal the sum of the forces to the right to maintain equilibrium. And I will then prove my plus and minus pictorial assumption. Sum of my forces to the right less the sum of the forces to the left should equal 0. So let's work out what these are. So I don't know all my forces to the right. Because that is a pinned support, it's going to have a force left horizontal. So first thing, positive, force left horizontal. How many others do I have? I don't have any because these are pointing that way, and therefore its force is going to be, its horizontal force is that way. He's pointing that way, so it's naturally going to be pushing that way. So it is minus. What is the horizontal force for the first angled load? It is pushing to the left, 173.2 newtons. And it needs to be added to the horizontal force pushing that way of this particular force, that angled force, which I've worked out to be 250. Force left horizontal less 250 plus 173.2, 423.2. Take that to the other side, it becomes a positive. Newtons. Force left horizontal. It's a positive, it tells me it's traveling in that direction, opposing those other two forces of 173 plus 250. Hope that makes perfect sense. Now, forces vertical, the same as before, where made a mistake there. To the right was positive, to the left was negative. I'm going to do the same thing on this side now. Plus positive, down is negative. How do I solve that? The sum of all my forces vertical should equal 0. Probably good to say that. Sum of all my forces down equals sum of all my forces up. I don't normally write it like that, but anyway. Take that across to the other side. Equals positive sum of all my forces upwards minus sum of all my forces downwards. Let's find all the forces pushing downwards. I have blocked the picture, but I think you've got the idea. How many forces do I have pointing upwards? I'm going to have my one unknown, and I've got that one that I know. All the others are pointing down, down, down. So it's all my ones going upwards, all my forces going upwards. So it's plus. What is my FRV? So I know what that is. That is 490.63 plus FLV. Subtract all the forces pointing down, and that is going to be, that one there is going downwards, 500. Remember, it's a sum of, so that plus the downward force, which is 100, and the downward force plus 433. So let's extract this out. So I've got 490.63 plus FLV, my force left vertical, minus those all added together. So what is that? 600 plus 433 is going to be 1033. Let's just sort that out. Force left that. 1033, because it's negative. So let me just do this. 490.63 minus 1033, negative 542.37 newtons. Take that to the other side. It becomes positive 542.37 4.37 newtons equals force left vertical. It is positive, therefore it is going up. A real quick and simple force diagram that I'm going to work out now. Here's my beam. I have a force there. I have a force there. On my left-hand side, I've just solved it. My force left vertical is 542.37 newtons. The horizontal is 423.2 newtons. This one is 490.63 newtons. I have 500 newtons. I have 100 down and 173.2 newtons that way. I also have 433 newtons and 250 newtons that way, all resolved to be 90 degrees, all parallel to that beam. Technically, I can add up all the downs should equal all the ups, and all the left should equal all the right should equal all the lefts. I think that's my answer. So if you guys have any questions, I don't normally say this type of thing, but just add some comments, jump on and I can extract anything further. I hope that helped, guys.